Pydantic AI's capability mechanism lets a developer extend agent behavior by subclassing AbstractCapability and passing an instance through the capabilities parameter of the agent constructor. The following code demonstrates a minimal custom capability that observes each node execution during a run. A NodeLogger instance is created with a default empty list, then registered on an agent configured for the OpenAI GPT-5 to model via capabilities equals logger, after which agent runs sync hello, triggers the observation and logger nodes is printed. From future import annotations. From data classes import data class, field. From typing import any. From Pydantic AI import agent, run context. From Pydantic AI, capabilities import. AbstractCapability. Agent node. Node result. Wrap node run handler. At data class. Class NodeLogger AbstractCapability any. Logs each node that executes during a run. Nodes. List SDR equals field default factory equals list. Async def wrap node run. Self CTX. Run context any asterisk node. Agent node any handler. Wrap node run handler any. Node result any. Self nodes. Append type node name. Return await handler node. Logger equals NodeLogger. Agent equals agent OpenAI. GPT-5 2. Capabilities equals logger. Agent run sync hello. Print logger nodes. User prompt node. Model request node. Call tools node. This is a custom capability that hooks into the agent graph lifecycle via wrap node run. The NodeLogger class extends AbstractCapability and overrides the hook to append each node's type name to a list as the run progresses. The logger is passed to agent through the capabilities parameter, and after running the agent, you can inspect logger nodes to see the execution order. The pattern here is straightforward middleware. Wrap node run receives the node and a handler, logs the node type, then delegates to the handler. This gives you per node visibility into the graph traversal without modifying the agent's behavior. It's a minimal example of how capabilities intercept lifecycle events, and the same wrap pattern applies across model requests, tool execution, and output processing. Trade-off: this is observation only, it doesn't modify graph progression. If you needed to control flow, like limiting model requests, you'd add conditional logic before calling the handler, as shown in the max model requests example in the docs. For production tracing, you'd likely want to include node metadata beyond just the type name, but the hook point is the same. Let's break it down line by line. From future import annotations. Enables postponed evaluation of type annotations, deferring their evaluation until runtime so forward references aren't evaluated at import time. From data classes import data class, field. Imports data class and field from the standard library data classes module for defining classes with automatically generated init and other dunder methods. From typing import any. Imports any from typing for type hinting. From Pydantic AI import agent, run context. Imports agent and run context from the Pydantic AI module. From Pydantic AI, capabilities import. Imports from Pydantic AI, capabilities, beginning a selective import of capability-related classes. AbstractCapability. Imports AbstractCapability, the base class for defining custom capabilities in Pydantic AI. Agent node. Imports agent node from the Pydantic AI framework for use in this module. Node result. Trivial syntax skip. Wrap node run handler. imports wrap-node-run handler, a handler class for node execution in Pydantic AI's runtime.
At data class NodeLogger AbstractCapability any. Logs each node that executes during a run.
Defines a data class NodeLogger subclassing AbstractCapability any, with a docstring describing its purpose as logging nodes during a run.
Nodes list str equals field default factory equals list.
Declares a field named nodes, typed as a list of strings, with an empty list as the default value using default factory equals list.
Async def wrap node run.
Declares an asynchronous function named wrap-node-run with an opening parenthesis for its parameter list.
Self ctx run context any asterisk node agent node any handler wrap node run handler any.
Declares a lifecycle hook method accepting run context, the current agent node, and a node run handler as keyword-only parameters.
Node result any.
Trivial closing syntax for a function return type annotation.
Self nodes append type node name.
Appends the class name of the node object to the self nodes list.
Return await handler node.
Awaits the result of calling handler with node as the argument, then returns that result.
Logger equals NodeLogger.
Creates a NodeLogger instance and assigns it to the variable logger.
Agent equals agent OpenAI. GPT-5 2. Capabilities equals logger.
Instantiates an agent configured to use the OpenAI GPT-5 2 model and attaches a logger capability to it.
Agent runs syncallo.
Calls the agent's synchronous run method with the prompt hello, blocking until a completed response is returned.
Print logger nodes.
Prints the node's attribute of logger to stdout. The whole thing is middleware for the agent graph. Use subclass AbstractCapability, override wrap-node-run, log the node type name, then hand off to the handler. That same hook point exists for model requests, tool execution, and output processing. The NodeLogger example keeps it simple, observation only, no flow control, but the pattern scales to conditional logic like limiting model requests if you need to. Pass the capability instance through capabilities equals, run the agent red logger nodes. Done.
A list holds nothing, yet here's every node name before handler run.